understanding of blockchain till we understand all the technical concepts which are mentioned in the white paper. So let me just share my screen with you guys. I hope all of you are able to see my screen. It should say understanding the Bitcoin white paper. It's a PowerPoint presentation. Awesome. So now the first thing that we need to know when we look at the white paper, right on top it says it is a peer-to-peer electronic cash system. And this is the reason when a lot of people say they are investing in Bitcoin, it makes no sense to me. Because Bitcoin is not supposed to be an investable asset. It is supposed to be cash system. What do we use cash for? It does not make sense for anyone to take a 100 rupee note and lock it in their drawer for 10 years. That is not going to grow in value. In fact, it is going to fall in value. That's what inflation is all about. Now, Bitcoin was supposed to be created as a cash system. That means you would use it as a medium of exchange, send money and receive money. Unfortunately, a lot of people have converted this into a so-called asset, and that's absolutely the wrong way to look at it. So the heading itself shows us it's not supposed to be an asset. It's supposed to be a medium of exchange. Now, when we look at the abstract, there's a very important term that I need you to understand and see here, which is marked in red, and that is called double spending. Now, this is a very, very important concept. The reason that before Bitcoin, we did not really have any workable cryptocurrency is that the problem of double spending was not solved. Now, what does double spending mean? Let's say I take a 100 rupee note and give it to you. I cannot spend that note again because I have already given it to you. However, in the electronic form, if suppose I was to create a Word document in which I say I owe you 100 rupees and then I digitally sign it and send it to you by email, nothing is stopping you from making 100 copies of that and now asking me to pay 100 times the amount. So in the digital world, copy pasting or duplicating an electronic content is very easy. And because there was no solution to it, we didn't really have a workable electronic currency. So that is the reason that Bitcoin came out with this innovation. I hope the slide is visible to all of you. It's the slide which says abstract on it. Oops, it's on the first slide. Okay, I hope it's better now. Yeah, great. Okay. So here, that is the double spending that I was talking about. So of course, we are going to go into detail about how this problem has been solved. Another thing, if you look here, what the Bitcoin white paper has done is, it has made a solution to the double spending problem using a peer-to-peer network. This network timestamps transactions by hashing them into an ongoing chain of hash-based proof of work, forming a record that cannot be changed without redoing the proof of work. Now, I'm presuming 99% of you would probably not understand what they're trying to say in this. And don't worry, by the end of the session, you would have a very clear understanding of what they're trying to say. But if we just break it down for now, we are going to find a solution to this double spending problem. It is going to be a peer-to-peer network, which basically means there's no central authority controlling it. Anybody in the world could connect to it. That is where the concept of a node comes in. Then this network, so in the blockchain world, you keep hearing about the word network. Network simply means a bunch of nodes connected to each other, and each of these nodes is running the blockchain software. So we call it the network. This network is going to use something called a timestamp, which means every transaction which is happening, a time will be put on it. Exact time. When did this transaction come for processing? Then there is going to be something called hashing, which we are going to see very soon. And the network is going to take these timestamps, put them on a chain, a blockchain, so to say, which is going to be hash-based and proof of work. So you've all heard that the Bitcoin algorithm consensus mechanism is proof of work. So we're going to see what that means. And finally, a very important thing, forming a record that cannot be changed without redoing the proof of work. Now here, let me take a short pause and give me a second. Okay, I've stopped my screen. I hope all of you are able to see me, right? Just a quick yes, so I know I'm clearly visible to all of you. Okay. Now the point I want to make here, and I want all of you to understand this. Even today, Bitcoin has been going on for more than 10 years. I have a question for you. Is it possible that today somebody can override the entire Bitcoin blockchain, all the transactions, can they be changed today in one single day? What does anyone think? So Ritu says no. Okay, a lot of people say no. Okay, there's just one person, I think Keshav, who said yes. Well, the answer actually is yes. It can be changed. Now you're all going to be shocked thinking, no, Bitcoin is supposed to be immutable. Actually, Bitcoin doesn't use proof of work. It uses a variation of proof of work, which we call as the Satoshi, or you could call it the Nakamoto consensus, which uses probability. If any of you have ever looked at the Bitcoin white paper, at the end you would see this very complicated looking mathematical equations. We are going to see them later. What they're trying to say in those equations is the probability of an attacker overwriting all these transactions and creating a new chain is low. And as more and more blocks are added, the probability reduces. But please remember, it's not a guarantee. We are going to see that slowly. But one thing which I want all of you to understand is the entire Bitcoin blockchain could be changed in one single day, or rather one single block, which could be maybe in a 10-minute interval. And slowly we are going to understand how that really happens. I hope everything's clear till now, not too complicated. We're going to get slightly more complicated soon. Okay, let me just quickly share my screen again. So now I'm going to go a little deeper into double spending. So I hope this screen is visible to you, which says double spending on top. Now, the first thing is, can you double spend physical currency? Obviously not, because if it is a physical currency note, once you give it to someone, you cannot spend that note again, right? Now, can you double spend a virtual currency? If an electronic record is taken, yes, it can be done. But if we have a digital currency which cannot be spent multiple times, that is Bitcoin. So the real innovation of Bitcoin was to solve this problem of double spending. Now, I hope you can see a screen which talks about the introduction. Now, in this, again, I've marked out certain areas which are in red, and that's the only part that we need to focus on. So firstly, we can see completely non-reversible transactions are not possible in the real world, because financial institutions have to come in when there is a dispute. So suppose I make a payment to you by credit card, you don't send me the stuff I ordered, I can go to my bank and they can reverse the transaction. So in the real world, all transactions are reversible because you have a party in the middle, you have a bank, or you have a credit card processing agency, they can reverse it. And because these agencies have to spend time, money, and people on solving problems that customers have, transaction cost naturally goes up. And here again, they're saying merchants have to be wary of their customers because they know that sometimes customers can commit a fraud. And in fact, here, if you look at the last part, a certain percentage of fraud is accepted and as unavoidable. Now, why I'm reading all this to you is I want you to understand that Bitcoin was not created, to sort of remove governments from the picture. That is a narrative which people have built over time. No, they were actually trying to solve a very logical problem. That in the current world today, especially when we do internet commerce, there are certain problems which make transactions reversible and expensive. So that is the problem statement with which Bitcoin actually started. If you have any questions, please feel free to post them. Now I'm shifting to the next slide where there would be something in green here. I hope you guys can see that. So in this sentence or two sentences, Bitcoin's actually defined. It is a solution to the double spending problem using a peer-to-peer distributed timestamp server to do what? To generate computational proof of the chronological order of transactions. Very critical. The order of the transactions cannot change. So, you may have heard about that in the blockchain world, we have a concept called flash loans, right? So when we talk about flash loans, you can borrow money and repay that money in the same block. Have you guys ever heard of that concept? I'm sure many of you would have. Don't worry if you find this a little difficult. It'll start to get simpler very soon. So I'm sure you guys have heard about this concept of flash loans, right? So the order of transactions is important because in a flash loan, I can take a loan in first transaction, repay it in the 10th transaction in the same block. So in the real world, when we take loans, they are for a longer period. But in the blockchain, we can take loans for even seconds and minutes. So that is why this chronological order becomes important. And the system is secure as long as the honest nodes collectively control more CPU power than the attacking node. So, you may have heard about a concept called a 51% attack. What does that really mean? It means that the attacking parties have more than 50% of the mining power of the blockchain. And if they have it, they can rewrite it and make fake or false transactions. So Bitcoin admits that the system is going to be secure only till the honest guys have more than 50% control. If they lose that control at any time, it doesn't matter how good the Bitcoin technology is, the whole transactions would become falsified. And that's going to create a huge problem. Any questions so far? You guys can feel free to type it in. Okay. I have an interesting question. What is the need for irreversible transactions from Abhishek? Yeah, that's a very good question to ask. So let me just go stop sharing and let me take some questions right now. Why do we need irreversible transactions? Because I think reversible transactions can sometimes be very unfair. Now let's take an example. Not just reversibility, but when Russia recently had this embargo put by the US because of the Russia-Ukraine war, a lot of people who are, maybe citizens of Russia who had nothing to do with the war suddenly are not able to use their cards, for example. Now, why is that? That's because there are centralized agencies controlling the whole thing. And they can reverse transactions, they can stop certain people from participating in transactions. So the Bitcoin creators wanted a system where they would be able to stop this, where transactions could be irreversible. Once it goes through, nobody can really do anything about it. Someone's asked if we are recording it. Yes, we are. Okay. Hitanshu's question is, let's say there are already 10 transactions in the queue, including your first one. If the second transaction of flash loan is stored in the second block, yeah, then in that case, it's over. That thing won't happen. But don't worry, we are going to come to flash loans later. That's a much more complex issue. So right now, I just wanted to give you the basic introduction. Now, let me quickly jump to something called hash functions. Give me a second. Okay, now you should be able to see on your screen a screen called hash functions. I hope that's visible to you. Yeah. So now let's understand, because this is the most important core concept of a blockchain. A hash function is a mathematical formula. It is going to take any input. So whether you give it a single word like the word Sanya, or you give it a file like a PDF, doc, it doesn't matter. Any electronic content can be given to this formula as an input, and in return, it will generate something called a hash. So now let's have a look. When I use the word Sanya, all small letters, it gives me this long looking hash here. If you count it, it is 64 digits. Now, when I make that Sanya word into all caps, it is again giving me an output which is still 64 digits. But as you can see, the output has changed. Now, if I use only the S capital, everything else small, again, it's a different output. Obviously, when I use Word files and PDF files, different outputs are coming. But a very important thing for you to remember is, if I give the same input, this all small letter Sanya, no matter which computer in the world I use, what operating system I'm using, which software I use, as long as I'm using the same mathematical formula, which in this example is SHA 256. You can see that right on top. So if I use the SHA 256 mathematical formula, whatever input I give, I will always get a 64 character output. And if I give the same input, I will get the same output. But if I change even a single dot in a 100-page document, like here I have a PDF document which could be 100 pages. If I change even one full stop in that 100-page document, the hash will completely change. Just a single dot changes it. And that is why whenever we say provable immutability, It is because of hash functions. So we are going to soon see how Bitcoin uses hash functions, but this is what it really means. Now, let me give you a little more introduction to it. So as I explained to you, the hash function takes an electronic record, which could be anything, say a PDF, a file, a video, an email, and produce a fixed length output, which in this example was 64 character. Now, if this information is changed in any way, even a comma in a 3000 page document, a different output is produced. And finally, it is computationally infeasible to calculate the original record from the hash. So if I only give you a hash and I say, okay, now try to figure out what was the original, well, it's not possible to do it, because it would take far too much computational power, because the number of hashes possible is so large that all the world's computers will not be able to reverse the hash, which is why we say it is a one-way mathematical function. It can go from input to output, but you can't really reverse that. I hope that was simple and wasn't too complicated. Let me just come back and take some questions. Okay. Now, let me see some of the questions. Give me a second. So both the traditional and blockchain based will coexist, not eat each other. Okay, if you're talking about it from a payment point of view, I have no doubt in my mind that blockchain will not replace the conventional world, nor will cryptocurrencies replace the conventional world. That is just, people who, I don't know, for whatever reason, they keep creating this news. No. I mean, when you look at the beauty of, say, something like a UPI in India, and which is now being rolled out in other countries, blockchains cannot handle that, right? They don't have that kind of speed. They cannot handle that level of, fast transactions. So they both have their positive and negative points. Now, someone's asked, Abhay asked, what is the future of SHA 256? Can it be reversed? Excellent question. Yes. So if we look back in the past, earlier we used to use a formula called MD2. Somebody broke it. MD5 came. Somebody broke it. SHA1 started. In fact, I think it was Google who broke SHA1, then SHA2. So yes, as time progresses, as computational power gets better, then hash algorithms are broken and new ones come in. Well, as of today, SHA 256 is not broken. SHA 512 is also there. So as one breaks, the next level comes up. So that's kind of how it happens. Okay, I think those were the only questions I could see so far. So great. Let me just head back. Let me share my screen again. Now what I'm going to do is I'm going to explain some very basic crypto concepts. Cryptography. Actually, the original of crypto is always cryptography. Now it's considered cryptocurrency. The first concept we need to understand is called symmetric crypto, which is simple. You have a plain text, hello, hi, whatever you've written. You will use a key, which could be like a password, and you will encrypt it, which means convert this plain text readable thing into ciphertext, which you can't read and understand. It just looks like some bundle of complicated text. But the same key can be used to decrypt it. If I give you a real world example, the door in your house, you have a key. You use the same key to lock and the same key to unlock. So in the world of cryptography, when we use the same key to encrypt and decrypt, that is lock and unlock, we call that concept as symmetric encryption. Now, if we are going to use two different keys, we are going to call it asymmetric. And you'll wonder, how is it possible? How can we have two different keys? And again, I'll give you a simple example. If any of you have ever gone to a bank locker, now in a bank locker, you will notice that when you want to open the locker, you need two keys, the bank manager's key and your own key. Only when the two keys come together, the locker opens. When you want to lock, you only need your own key. So that's similar to this example. In asymmetric cryptography, every person generates two keys for themselves, a public key and a private key. Now, when somebody wants to encrypt information and send it to me, they will use my public key and lock that information. And I will be the only person who can unlock, because only I have my private key. So I will use my private key to unlock that information. Now, why I'm talking to you about public and private keys is because this is the most important concept in your own wallets. Like, in the world of blockchain, we use wallets. What is a wallet? I'm going to do it in detail later, but very simply, It is your private key and your public key. You use your private key to sign transactions and move crypto out of your wallet. And your address, which people can send crypto to you on, is actually your public key in a certain hashed format. So asymmetric encryption is actually what the whole of blockchain world runs on. I hope this was simple. Let me read a couple of questions. Is it possible for a quantum computer to bring the whole blockchain technology down? Yes, it is possible. So when we talk quantum, what we're basically saying is really powerful computers, millions of times more powerful than what we have today. And that is why I started in the beginning and told you the entire Bitcoin transaction ledger can be rewritten instantly if we have an extremely powerful computer coming in. So yes, to answer your question, Soham, that's possible. Nitin says, from what I read, SHA-256 was created by NSA. What if someday NSA makes the decryption algorithm public? So actually, no, it is already public from day one. All these algorithms are open source. Everybody in the world can read the formula and implement it into software. So don't worry about it. Knowing the source code doesn't reduce the security. In fact, it improves it. Everybody in the world can see it. People have tried their best to crack it. They were not able to do it, which is why it is being used. Nitin also says, when a public and private key is getting created for a wallet, how are they related? That's a very good question. So as a homework after this session, I'm going to make you read a document in which I've actually explained this with the mathematical formula, where we are going to start with two prime numbers and then do some complicated math with it and generate a public-private key pair, which is related to each other in such a way that anything encrypted with a public key can only be decrypted with a corresponding private key. So if your public key was used to lock the data, my private key cannot unlock it, only your private key can. That's how the mathematics works. I hope that's all clear so far. Someone's asked a question from LinkedIn. How many transactions can be added in a block? So give me some time, I'm going to come to that, because in Bitcoin there is a certain number of transactions, in other blockchains there are different, but I want to explain to you why that number is different and how that number is actually calculated. So we'll come to that in some time. Now I hope on the screen you can see something called digital signatures. I hope that part is visible. Kodo, if you could just ping me saying that, yeah, that's visible. A screen called digital signature. Awesome. So now if you look at it, and this is critical because in a blockchain, every transaction is digitally signed. And this is kind of how it works. There is some original text, which could be, I am giving you your address so-and-so. I am giving you 1 Bitcoin as a payment. That original information is signed by my private key. Now, if you realize, it's a little different. In the earlier slide we saw, we are encrypting data. So you used my public key to encrypt data and send to me. I unlocked with my private key. Here it's not that. I am now using my private key to digitally sign the data. You are going to use my public key, which anybody in the world can get from 1,000 places, which I'll show you. And they can then verify whether I signed or not. If someone tampered the message, immediately you will come to know it is not valid because the validation will fail. And I'll show you what that validation also looks like. Now, let's have a look at what these actually look like. So this is a very simple example of a private key. And this is a simple example of a public key. So here, as you can notice, I have used ECDSA, which stands for Elliptical Curve Digital Signature Algorithm. So that is one of the most popular today, used by most of the blockchains. So that's the reason I'm talking about it. Now, many of you may say, no, SHA is used. That is a hash algorithm, different. This is a signing algorithm. So please remember, there are actually multiple algorithms at play. Hashing algorithm, I explained already to you, that's hashing. This is signing algorithm, they're totally different. So you cannot sign with SHA and you cannot hash with ECDSA. They're totally different. So this is what a private key looks like. This is what a public key looks like. This could be a sample data, and this is what a digital signature looks like. So to be able to verify whether you have signed something, I need your public key, I need the original data, and I need the digital signature. All three things are needed. But to sign, you need only private key and the data. I hope this part is clear. No questions so far. Why private key is used for signing and public for opening? Well, that's the way the whole concept is designed, so that the whole world could, in a decentralized manner, I mean, and these algorithms for signing and all were created in the 1970s. And since then, they have been functioning in a beautiful manner. That's the way they are designed. Now, let me show you a practical example. So, there's an interesting software called GPG. It would be great if you guys can maybe download and try it out on your own, but I'm going to walk you through the steps here. And I'm going to show you how we actually create these key pairs. It is still not from the blockchain point of view. It is from the basic concept point of view. So when I open up this software, and almost all the softwares for this would look very similar, I enter my name, I enter an email address, then I have an option called upload public key. So, I told you that anybody can get hold of your public key. So where can they get it from? If I click upload my public key, it will go onto a public repository and anybody in the world can search using my email address. So if you want to see my older private keys also from the 1990s, I think, go to any of the public repositories and just look for rohasnagpal@gmail.com and you'll be able to get my keys, which I used to use even 20 years ago. So they are always available to the world. Then I select which algorithm I want to use. I can even select the length. So the longer the key, the more secure it is, because the more difficult it is to break. Then I can always put an expiry date and I can put a passphrase, which means even if somebody gets my key, they cannot misuse it till they have my password. Now, once I do that and I click a button, in a few seconds, I can see and then I can download my key. And this is what a public key looks like. It's huge. I've just shown you a small part of it. It's actually much bigger than this, but it's like a very large mathematical number. And this is a public key and the next one is a private key. They both kind of look similar. Looks like a huge bunch of text. And then once I have installed this, so obviously I have this GPG software running on my computer. Now here, if you can see, I can just right click on any file and this thing called services shows up. And now I can decide what I want to do. I want to sign a file, encrypt a file, I can do that. If I say I want to sign, it shows all the different keys that I have. I choose one, click on the choose button, and immediately it can create a digital signature which looks something like this. Again, if someone tries to tamper it and removes even one alphabet from here, it will fail and you will not be able to use it. Then anybody can download this file, I can email it to them and they can go to their software and say verify. And if nobody has tampered, then it will say, okay, verification result fine. If somebody has tampered the file or the signature, it will show in red and it will say verification failed. So that's a very simple overview of digital signature. So again, now let me come back and take some questions. And don't worry if it's difficult, it will get easier and you obviously have to re-watch this video later. And I'm going to give you some reading material which will kind of start to make things simpler for you. Shivam says if the private key is used for opening and is publicly available. No. Public key is available, private key is not. Private key is supposed to be kept with you. Like I'm sure you guys have heard the phrase, not your keys, not your coins. Have you heard that statement? A lot of people in the crypto world say it. In fact, I think Elon Musk was the first guy who started to say that. Yeah. So what does it mean? If somebody has your private key, they have your crypto. So a crypto is controlled like this. Anybody in the world can have your public key or your address and send crypto to you. It's like your bank account number. There's nothing secret. But if somebody gets your private key, your crypto is gone. So when you use a centralized crypto exchange, you don't have your own private key there. The exchange has it, which is why we say not your keys, not your coins. So Parth or Shivam, I hope you understand that the private key is never available. If somebody gets your private key, your crypto is gone or your assets are gone. What is the size of the private key and public key? So offhand, I don't have to recall how many KB it is, but I'll check it up and let you know, or you could just Google that. Roop has asked whether GPG tool is available for Windows. Yes, it is available for Windows also. So let me just go back to sharing my screen. Someone's asked if I will be posting the pre-recorded sessions. Yes, I will be. I'll be posting this session. And if someone has either seed phrase or private key, then can they get hold of a crypto? Yeah. So later when we talk about seed phrases and wallets, you'll understand the difference between a private key and a seed phrase. But yes, if they have it, all your crypto is gone. Okay, let me share my screen again. Now, moving on to the white paper, another very important point which the white paper talks about, if you look at the green part, transactions must be publicly announced, and we need a system for participants to agree on a single history of the order in which they were received. So now imagine you are in a decentralized world. There is no bank running Bitcoin. So obviously they needed to solve a problem that if there are millions of transactions happening all over the world, all of them are happening in a particular order. How do people, nodes which are in different countries, they don't even know each other. How are they going to agree that a particular order is correct or not? So that's a very important issue that needs to be solved. And to solve that, they spoke about a timestamp server. So this timestamp server is, how does it work? Again, look at only the green part. It works by taking a hash of a block of items to be timestamped and widely publishing the hash. Now, all of you know what a hash is. So the most critical part is that this timestamp server is not going to look at transactions. It is going to look at a hash only. So again, don't worry, we'll understand what this really means. And now we get introduced to proof of work. So Bitcoin says, what we are going to do is we are going to use a proof of work system similar to Adam Back's Hashcash. So this gentleman called Adam Back came out with this concept of Hashcash somewhere in the early 90s. And now this is the most important thing which I'm going to explain to you. And after that, I'll come and take your questions. So please focus. This is the absolute core of Bitcoin. When Adam created proof of work, he was not thinking about a currency. He was thinking about solving email spam as a problem. So the logic that he had was very simple, that today it is very easy for a spammer to send out millions and billions of emails, right? Now, how do we slow him down? So he said, can we make it difficult for the spammer to send out so many emails by forcing him to do some mathematical calculations? So he came out with this really cool idea. So if you look at the top here, so he said, and I've simplified this, the reality is a little more complex. Basic, let's take the email address of the sender. Let's add this small symbol. Let's take the email address of a receiver. Let's put a symbol. Let's put a timestamp for when this email was being sent. Let's again put a symbol, and at the end we put a nonce. Nonce is just a number. Starting with 0, it will keep increasing. 0, 1, 2, 3, 4, it will keep going. Right? Now, in this example that I've created, we are saying that when this entire string of sender, receiver, timestamp, and nonce goes through the SHA-256 hash, the resulting hash should begin with 4 zeros. So now you'll say, why 4? Well, just randomly I've taken 4. In Bitcoin, the number is bigger. The number of zeros is more. But the concept is very similar. So now let's take an example. We take an input. Input is sanya@example.com. Then we put this symbol. Then we put the receiver, samaira@example.com. Again, we put a symbol. Now we have put the timestamp. So this is the Unix timestamp of the exact time when the email went. And at the end, we are adding a 0. Now, when I run this string through a hash function, SHA-256, in fact, even you could try it on any hash calculator and you will get the same answer. Does it begin with 4 zeros? So as you can see, no, it doesn't. It starts with 6. So we will say 0 is not the nonce. We will go to the next step and we will make that number 1. And now when we pass the entire string, is it starting with 4 zeros? No. So we say 1 is also not correct. We will keep increasing the nonce. 0, 1, 2, 3, keep going up. And in this example, when we reach 161,000, and now we pass this string through the hash, the resultant begins with 4 zeros. So we can say one of the working hashes for this email string is 161,000. And this, when you hear miners have to solve a mathematical problem, I'm sure all of you have heard that term. Well, this is the mathematical problem that they are actually solving. Calculating a nonce such that the hash begins with a certain number of zeros. And the number of zeros determines the difficulty level. But don't worry, we are going to go into that also. So this is the heart and the core of proof of work. Calculating a nonce such that when an entire string of data, whatever the data is, goes through a particular hash function, the result begins with a certain number of zeros. And as you can see at the bottom here, infinite nonces can exist for any given string. Like 161,000 is not the only hash, sorry, not the only nonce which will give you 4 zeros. No, there are unlimited number, but it will just take more time to calculate. And the rule here is, in Bitcoin or in any proof of work, just get one which works. You don't have to get all of them. You can never get all. Calculate the first nonce which fits. And calculating this nonce is not trivial. It takes huge amounts of mining power. But verification happens in a millisecond. Now, to calculate this nonce, I had to do 161,001 transactions because I started with 0. But to verify, when I gave you the nonce, you just run one string through the hash function and come to know whether it is correct or not. So as you can see, calculating the nonce is a hugely expensive affair. In this example, it's simple. But in the real world of Bitcoin, there are so many miners competing with each other. So they have to calculate millions and billions of hashes every second. In fact, trillions. And only one nonce, if you find which works, you can end up mining a block. But we are going to go deeper and deeper into that soon. So now I'm giving you one example before I again come back to answer your questions. Now I wrote a simple PHP script. I hope you guys are able to see that. First, let me show you the what the script does. It simply takes this string and tries to calculate which are the nonces which work. So kind of I'm trying to replicate the mining concept, but I've written a very simple script in PHP. So if any of you want the script, just email me and I'll give it to you. I presume a lot of you may not already be developers, so I didn't want to scare you with code on the first lecture. A simple PHP script which can calculate all the working nonces, which means that which are these nonces, which when put after this string will give us hashes beginning with 4 zeros. And here we can see 1,61,000, 202,312, 2,901. So like this, you will find there are unlimited nonces which can fit in and give you the correct answer. So now what I'm going to do is, I am going to take a pause and come to answer your questions. Give me a second. Okay. So now I understand for a lot of you this would have been complex, so don't worry about it. You can go through the video. I'm not going to go on to the next concept. This is part 1. Next concept we'll go to is part 2. So right now let me explain to you. Tushar asked, how does it solve the spamming problem? So Tushar, what it did was, it forced the sender of the email to do the mathematical calculation and send a nonce along with the email. And that took time. But in reality, nobody used it. So Gmail, Hotmail, nobody used proof of work. So that system was just invented, but Bitcoin used it, which is why we got into the detail of it. Gorley has asked, does number of zeros vary from chain to chain? Yeah, we are going to go deeper into this. So we are only talking proof of work, and the number of zero not only changes from chain to chain, in Bitcoin also it changes every 2 weeks or every, I think, 2016 blocks. Remember, in the world of blockchain, we don't use normal time, we use blocks to indicate time. So every 2016 blocks, the system checks how much time did it take to generate a block. If it is more than the average time, or which should be 10 minutes, it will simplify. If it took less, it will make the difficulty level more. And the difficulty level directly changes the number of zeros. We are going to do that. You're going to see that in a lot more detail. How many nodes are miners? So that's a very good question, Bhushan. I've made a post on this. So just go over to my Instagram and I made a post called What are blockchain nodes? In that, I've explained to you there are different types of nodes. Mining nodes are one category. All nodes don't do the mining. Number of nodes, it changes all the time. So don't know the exact number. Ashish has asked if some unintentional error is made in blockchain, is it possible to correct it? So when you push anything to the blockchain, you cannot change it, but you can add more data. So you can add something saying that earlier information is wrong, but you cannot change the information that has already gone. Very difficult, but okay. There won't be an intentional error. Okay. So I can see as of right now, these are the only questions that have come up. So let me see if there are any others. Give me a second. How will miners know when to generate a block? So this we will do in the next session. We right now have to understand the basic concepts, right? So we've understood a little bit about encryption, decryption, digital signatures. We understood the meaning of hash, and we understood simplistically how proof of work actually works, right? So now what we are going to do is I'm going to put, of course, this video will be available to you on YouTube. And I'm also going to add some homework in the comment below the video, and I'll put it on the LinkedIn group also, so just go and check it. After you finish reading the material I've given you, and please rewatch this video at least once, your concepts will be much clearer. And then next week, we are going to go to the next level, and things are going to get a little more complicated. So today what we did was slightly easier. Next week, it'll go slightly more complex. Mayank has asked my email ID. You can just directly send it to rohasnagpal@gmail.com. So fortunately, because my name is pretty unique in the world, I get Rohas Nagpal as a username everywhere. So any social platform, it's just Rohas Nagpal. So yeah, there is somebody, by the way, who's created fake accounts of mine on Instagram and all. Please don't follow those people. I will never DM you asking you about trading and asking you to give money for trading advice. So please don't trust those guys, and look at the username. They'll always be Rohas Nagpal with some underscore or symbol at the end. The YouTube channel again is just Rohas Nagpal. Like I said, my username across the world is just Rohas Nagpal. Thanks, Abhay. Glad you liked the session. Difference between, Rupesh asked, difference between hashing and signing algo. Yeah, sure. So the hashing algorithm takes the input and generates that 64 character or the output. A signing algorithm takes the input, takes the private key, then does the calculations and generates a digital signature. So their objectives are totally different. The homework I am giving you will show you a signing algorithm in great detail. What if two miners find the nonce at the same time? Very good question. I'm going to cover it next time. In fact, you will be surprised to know this happens all the time. And that is why the blockchain keeps splitting into multiple chains. And then after some time, certain chains are deleted. And that is why we wait for a certain number of confirmations or new blocks to come before we trust a transaction. Which is why a UPI transaction can go through in seconds. But in a Bitcoin transaction, we wait for 60 minutes. Why? I'm going to be explaining that next time. Hitanshu says he got a DM just like that. Please, those are fake guys. Don't please give them any of your money. What if in future miners start making communities and they can tamper transactions? I'm going to come to that. There are lots of things that miners can do. And it's not in future, they're already doing it. We'll discuss that. Somebody wants to know where to get the doc file. I don't know which file. Are you talking about this presentation or which doc file? Hash may contain special characters. No, hashes don't contain special characters. Actually, they are numbers. They are in a, like as human beings, we use decimal. Computers use binary and hexadecimal. So I'm going to show you hexadecimal in the next lecture. Don't worry about that. Yes, Ashish, you will get the reading material very shortly. I'll put it below that. Any books which you can suggest? No, you don't need any books with it. Whatever you need, you will get from my videos. You will get from the carousel post that I'm creating on Insta. Don't worry, we'll go in deep. You don't need anything else right now. Where do we find eligible miners? So there are lots and lots of platforms where you could. So there are some miners where you can join them. Go to a site called NiceHash. You'll get a lot of good information there about mining. Bitcoin transaction takes time because of confirmation. No. So the transaction goes through within 10 odd minutes, but we wait for more blocks. I'm going to explain next time why. Private blockchain developer can Okay, Mayank, unfortunately, I'm not able to understand your question. Rup has asked, where's the white paper link? So just go to bitcoin.org. You will get the white paper. I'll put the link below the video. Don't worry about that. Or you could just Google Bitcoin white paper. You'll get that easily. So the recorded session, like I said, yeah, Rashmi, somebody's posted the link to the white paper. Just click on that and you can get it. And just remember, please keep checking on the official LinkedIn group. Every session later, I'll be putting up the link to the video and your homework and everything there. Yeah. Janvi's asked an interesting question. Why electronic coin called as a chain of digital signatures? That's there in the white paper. We're going to do all that next time. Don't worry about it. Yeah. So awesome. It was nice speaking to all of you. I hope you enjoyed the lecture. Please go through the video again, go through the homework, and I'm going to see you. Okay, these are the ones, the PPT for today's session. I'll put that link up also. Okay. So see you guys. See you next week. And by the way, if you guys want the Hindi version, that session is going to start at 8 o'clock again on Creator itself. So, but it's on a different channel. So I'm sure you have the, Vivan, would you be able to put the link here for the Hindi one, which we are going to start now in a few minutes? Okay. So I'll see you guys. Take care. Bye-bye.